I hope all of you are doing good. Let's start today's chapter, Rational Numbers. Introduction. In our previous classes, we have learnt about natural numbers, whole numbers, integers and fractions, and also studied about various operations on rational numbers. In this chapter, we shall study the properties of the operation on rational numbers. Okay. First, let's learn what is rational number. A number which can be written as P by Q, where P, Q are integers and Q is not equals to 0 is called a rational number. Thus, an integer divided by a non-zero integer is called a rational number. And division by 0, you know that division by 0 is meaningless. It is not defined, right? In rational number P by Q, P is called first integer or numerator and Q the second integer or denominator. The word rational has been derived from the word ratio, which means division. Okay. For example, all these are rational numbers. Okay. Natural numbers, whole numbers, integers and fractions are rational numbers. Since a natural number n is equals to n by 1 is equals to an integer upon a non-zero integer, every natural number is a rational number. Okay. Now, 0 is equals to 0 upon any non-zero integer and is therefore a rational number. All numbers and 0 being rational numbers imply all whole numbers are rational numbers. Okay. Number 3, any integer like -3, -2, -1, 0, 1, 2 and so on can be written as P by Q, where P is the given integer and Q is the one is the non-zero integer. Thus, every integer is a rational number. Number 4, a fraction is equals to x by y, where x and y are natural numbers, that is positive integers. Thus, every fraction is equals to an integer upon a non-zero integer and is a rational number. The value of fraction a by b doesn't change when both its numerator and denominator are multiplied by or divided by the same natural number q. So, all natural numbers, whole numbers, integer and fractions are rational numbers. Okay. For example, we can write 3 by 4 as 3 by 4 into 1 into 1. Okay. Then you can multiply both numerator and denominator by 2. So, you will get what? 6 by 8, or you can also like you will multiply by 4 and 4. Okay. And we say that fractions, these are equal. Similarly, these fractions are also equivalent. So, in general, any fraction a by b is equals to a into k upon b into k, means we should multiply numerator and denominator by same digit, or we should divide by numerator and denominator by same digit. Okay. Here k is any natural number. Okay. So, if p by q is a rational number, then number 1, p by q is equals to p into m upon q into m, where m is a non-zero integer. Number 2, p by q is p divided by m, q divided by m, where m is a non-zero exact divisor of both p and q. Positive rational number. A rational number is said to be positive if its numerator and denominator are either both positive or both negative. For example, these are positive rational numbers. Okay. Negative rational number. A rational number is said to be negative if its numerator and denominator are of opposite sign. For example, -6 by 5 and 7 by -8 are negative rational numbers. Equivalent rational numbers. If p by q is a rational number and k is a non-zero integer, then p by q is equals to p by q into k into k. For example, if you notice this example, and these are rational, equivalent rational numbers. So, such rationals are called equivalent rational numbers, right? Let's do example 1. Write the numerator and denominator of the following fractions. This is numerator and this is denominator. Okay. And number 2, identify the positive or a negative rational numbers. Okay. See, first one is, this is negative rational number, this is also negative rational number. Okay. Rational number in standard form. When a rational number has been expressed in such a way that its denominator is positive. Number 2, the only common divisor of numerator and denominator is 1, then the rational number is said to be in standard form. Example, m by n is in the standard form if n is greater than 0 and only exact common divisor of its numerator and denominator is 1. For example, all these rational numbers are in standard form. Okay. Now, equality of rational numbers. As we have seen that a rational number can be written in many or indefinitely forms, we can say that two rational numbers are equal if they have some standard form. Number two, if after expressing both of them with the same denominator, that is positive or negative, the numerators are also equal. Okay, for example, minus 14 by 21 and 12 by minus 18. These are equal. Okay, let's do example 1. Express in standard form 183 by 126 minus 126. Okay, so what will you do? You will multiply by minus 1 here also. Okay, so minus 183 by 126. Okay, which has a positive denominator. Now we will express it in standard form. Okay, so we will divide these, that is numerator and denominator, by 3. So we will get minus 61 by 42. Okay, so this is the standard form of this rational number, right? Representation of rational numbers on the number line. Let us recall the representation of natural numbers, whole numbers, integers and rational numbers on a number line. Natural numbers, okay, we represent natural numbers on a number line like this. The line extends indefinitely only to the right side of 1. Number 2, whole numbers, the line extends indefinitely only to the right side of 0. No number lies left to 0, okay, as you can see in this number line. And integers, the line extends indefinitely on both sides of zeros, that is towards the right side and towards left side. So no number lies between any two consecutive numbers, that is 0 and 1, minus 1, and 0, 2 and 3, etc. Number 4, rational numbers. The line extends indefinitely on both sides of zeros. We see number lines between 0 and 1 is 1 by 2, 0, and minus 1 is minus 1 by 2, 1 and 2 is 3 by 2, minus 1 and minus 2, and minus 3 by 2, etc. Note, the points representing the pairs of rational numbers, say 1 by 2 and minus 1 by 2, 3 by 2 and minus 3 by 2, are reflections of each other in a 0 or mirror image about 0. Okay. Example 1, you have to represent all these rational numbers on number line. Okay. So first we will divide the segments between each pair of consecutive integers into 3 equal pairs. Okay, because the denominator is 3, and then we get all the ask points which are shown in this figure. Okay. Order properties of rational numbers. There are 3 properties of order relation. Number 1, for any rational number p, exactly one of the following is true. Either p is greater than 0, or p is equals to 0, or p is less than 0. Number 2, for any 2 rational numbers p and q, exactly one of the following is true. P is greater than q, or p is equals to q, or p is less than q, right? This is called trichotomy property. Okay. And number 3, if p, q and r are rational numbers such that p is greater than q and q is greater than r, then p is greater than r. This property is called transitive property. Okay. Note, if 2 numbers are plotted on the same number line, then the number lying on the right of the other will be greater, and if both the numbers are represented by the same point on the number line, then we say that the numbers are equal as shown in the given figures given below. Okay. Now, comparing rational numbers. A positive rational number, a fraction, and 2 positive rational numbers can be compared like 2 fractions as discussed in previous classes. Further, each rational number is either it is positive or negative or a 0, right? So, every positive rational number is always greater than 0. For example, okay, 6 by 7 is greater than minus 1 by 2, 6 is greater than minus 5. Okay, number B, 0 is always greater than every negative rational number and less than every positive numeral. For example, as you can see here, however, we do not need a method for comparing 2 rational numbers having the same sign, that is both being either positive or negative. Method of comparing rational numbers. Express both the rational numbers in standard form, that is a rational number with positive denominator. Then each rational number is written as another equal rational number so that both have the same denominator. And number 3, now the number having the greater numerator is greater. Okay. First example, we have to find the greater number in the following pairs of rational numbers. 0 by 11 and minus 5 by 7. Okay, see, as you can see, minus 5 by 7 is a negative rational numbers, and on number line the numbers 0 is to the right of any pointer representing a negative number. That is, since 0 is greater than any negative number, so this one is greater than minus 5 by 7. Okay. Exercise 1.1. Identify the rational numbers and then write the numerators and denominator. 5 is a rational number and write 1 here. So this is numerator and 1 is denominator. Okay. Addition of rational numbers. When we add rational numbers, we first express one of them as rational number with positive denominator. For addition purpose, we divide the rational numbers into the following 4 categories. A. When denominators are equal, let A by C and B by C be 2 rational numbers. Then addition of these 2 rational numbers will be A plus B by C. Okay. B, when one denominator is a multiple of the other denominator, let A by B and C by 2B are 2 rational numbers. Then A by B plus C upon 2B is equals to 2 into A plus C upon 2B. Okay. And see, when denominators are co-prime, let A by B and C by D be 2 rational numbers. Then A by B plus C by D is equals to what? A into D plus B into C upon B plus D. Okay. D. When denominators have a common factor, let A by KB and C by KD be 2 rational numbers. Then A by KB plus C by KD is equals to A into D plus C into B upon KBD. Okay. And difference of 2 rational numbers, that is subtraction of 2 rational numbers. Recall that subtracting an integer B from A is the same as adding the negative or opposite or additive inverse of B to A. That is A minus B. A minus B is equals to A plus minus B. Okay. The difference of 2 rational numbers is also defined in terms of addition. Thus, if P by Q and R by S are 2 rational numbers, then P by Q minus R by S is equals to P by Q plus, then in bracket, minus R by S. Okay. So, note now, to perform a subtraction, replace the number you are subtracting by its negative and add without neglecting that. Okay. For example, now let's do the example. Write the additive inverse of each of the following. The additive inverse of 2 by 8 is minus 2 by 8. Additive inverse of 2 by minus 9 is what? Is 2 by 9 only. Okay. Exercise 1.2. Write the additive inverse or negative of each of the following. Minus 5 by minus 8. Additive inverse of this is minus 5 by 8. Okay. Multiplication of rational numbers. We know that multiplication is a process of successive addition like this, as given in this example, or similarly 4 into 1 by 4 is equals to 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4 is equals to 4 by 4 is equals to 1. Division of rational numbers. As in case of whole numbers, integers and fractions, for rational numbers also we define division as the inverse of multiplication. If P by Q and R by S are 2 rational numbers, then P by Q divided by R by S is equals to P by Q into S by R. Okay. Example, we have to find the value of 3 by 5 divided by 7 by 9. So 3 by 5 into 9 by 7 is what? 3 9s are 27, 5 7s are 35. Okay. Exercise 1.3. Find the multiplicative inverse of the following rational numbers, that is reciprocal. Minus 11 by minus 11. So we have to find the multiplicative inverse of this rational number. So it will be 1 by minus 11. Okay. Rational numbers between 2 rational numbers. To find a rational number between 2 rational numbers A by B and C by D, where A by B is less than C by D, we use this formula. Have A by B plus C by D. Okay. For example, we have to find the rational number between 1 by 2 and 1 by 3. Okay. So what is the formula? We will write half. This is A. of half plus 1 by 3. Okay, 1 by 2. Here LCM 6, 3 plus 2. 1 by 2 into 5 by 6. That is 5 by 12. Okay, only a rational number. 5 by 12 is a rational number between these two rational numbers. Now, alternate method to find many rational numbers. Okay, to find many rational numbers between two rational numbers, we can find many rational numbers between two rational numbers by finding equivalent rational numbers with a large common denominator. For example, we have to find rational numbers between these two rational numbers. Okay, so 1 by 3, we will make denominator same, so we will multiply by 20, and here also 20 by 60. Okay, then next one is 1 by 2. We will also make denominator of this rational number 60, 30 by 60. Now, between 20 by 60 and 30 by 60, there are how many integers? 21 by 60, 22 by 60, 23 by 60, 24 by 60, and so on. Okay, so these are the integers between 1 by 3 and 1 by 2. Okay, exercise 1.4. We have to find the rational numbers between 1 by 3 and 1 by 4. Okay, 1 by 3 and 1 by 4. So what will you do? You will make the denominator. Okay, let's make it 12. Okay, so 12 by 36. 1 by 4, 9, 9. 9 by 36. Okay, now how many rational numbers are there? You can write 11 by 36, 10 by 36. Okay, there are many infinite number of rational numbers between any two rational numbers. Okay, so here it is not mentioned that how many rational numbers I have to find. Okay, so these are, or you can write any one of them, right? Things to remember. Number 1, the number of the form P by Q, where P and Q are integers and Q is not equals to 0, are called rational numbers. 2, a positive rational number is said to be positive if its numerator and denominator are either both positive or both negative. Number 2, a rational number is said to be negative if its numerator and denominator are of opposite signs. Third, number 1, if P by Q is a rational number and M is a non-zero integer, then P by Q is equals to P into M upon Q into M. Second, if P by Q is a rational number and M is a common divisor of both P and Q, then P by Q is equals to P divided by M upon Q divided by M. 4, a rational number P by Q is said to be in standard form if P and Q are integers having no common divisor other than 1 and Q is a positive integer. 5, A by B is equals to C by D only when A into D is equals to B into C. 6, to compare two or more rational numbers, express each of them as a rational number with positive denominator. Take the LCM of these positive denominators and express each rational number with this LCM as denominator. Then the number having the greater numerator is greater. 7. If A by B and C by D are any two rational numbers, then A by B plus C by D is also a rational number. Number 2, A by B plus C by D is equals to C by D plus A by B. Means we have changed the order, but after changing order also the sum will remain same. Third, A by B plus C by D, then plus E by F is equals to A by B plus C by D plus E by F. 4, A by B plus 0 is equals to 0 plus A by B, that is A by B. 0 is called identity element for addition and of rational numbers. 5th, A by B plus minus A by B is equals to minus A by B plus A by B is equals to 0. Minus A by B is called the additive inverse of A by B. 8, if A by B and C by D are any two rational numbers, then A by B into C by D is equals to A into C upon B into D. And 9, if A by B and C by D are any two rational numbers, then this is also a rational number and A by B into C by D is equals to C by D into A by B. Okay. One more property is given here. A by B into C by D into E by F is equals to A by B into C by D into E by F. Number 4, A by B into 1 is equals to 1 into A by B is equals to A by B. 1 is called the multiplicative identity for rationals. 5, A by B into B by A is equals to 1. B by A is called the multiplicative inverse of reciprocal of A by B. 6, A by B into C by D plus E by F is equals to A by B into C by D plus A by B into E by F. 7. A by B into 0 is equals to 0 into A by B is equals to 0. 10. If A by B and C by D are two rational numbers such that C by D is not equals to 0, then A by B divided by C by D is equals to A by B into D by C. 11. Number 1. If A by B and C by D are two rational numbers and C by D is not equals to 0, then A by B divided by C by D is also rational number. Number 2. For every rational number A by B, we have A by B divided by 1 is equals to A by B, and A by B divided by A by B is equals to 1. 12. 1 by 2, then in bracket A by B plus C by D is a rational number between two rational numbers A by B and C by D. Remember this formula, okay? Okay students, I hope you have understood this chapter. Now you will do practice of the remaining questions.